This lesson is for Advanced Algebra, Lesson 8.4. I'd like you to begin today by making a prediction on a challenge problem like the one shown. What do you think the answer is to the square root of the square root of the square root of x? I'd like you to think about your answer right now and write it down somewhere. I'll give you time to do that. And we will come back to this problem at the end of the lesson. There is one other topic that I need you to look at today before we get into the main topic of the lesson. First off is the idea of a geometric mean. The type of mean that you've been probably used to using before is an arithmetic mean. And when you do an arithmetic mean, you add up all the numbers and you divide by however many numbers there are. A geometric mean is calculated in a different way. You take the nth root of the product of the numbers. So to illustrate how that looks, let's look at example 1 from your textbook. They have a sample of E. coli bacteria taken over giving different levels. And so there's 8 different samples and different levels or different counts of E. coli within each sample. So we would take these 8 numbers and multiply them together, because that's what a product is. And then we would take the 8th root because there's 8 of them. So you would type in 2 times 54 and so on, and then you would take the 8th root of that. What we're going to talk about today is how to deal with the 8th root on your calculator. But know that if they ask you to do a geometric mean, you just take the numbers, multiply them, and then take the root of however many numbers there are. Moving on to our main topic for today, is talking about radical notation for nth roots. We've recently talked about taking something and raising it to a fraction-powered exponent, and we've talked about how that's the same as taking the root of something. So hopefully these first few problems are going to look extremely familiar. They're just using different symbols from what we've been using in the past. Keep in mind that whenever it asks you to simplify, that means you will need to calculate and come up with a numerical answer in lowest terms as best you can. So on this first problem, this is the cube root of 27. This symbol here is referred to as a radical symbol, and then whatever numbers in front here represents the root. So the cube root of 27, we're used to taking that problem and rewriting it like this, raising it to the 1/3 power, but know that the meaning of it is what number times itself 3 times equals 27. So that's something that you're just going to have to know. And that would be something that you would only be allowed to use a baby calculator for. So hopefully you know that 3 times 3 times 3 equals 27, so 3 is the cube root of 27. Whether you do it with a radical symbol or whether you do it with a rational symbol, it works the same both ways. So moving on to a question like number 2, again, a baby calc question. You would be taking the 6th root of 64, which would be the same as you saying 64 to the 1/6 power. You're trying to come up with what number times itself 6 times would equal 64. And so since 64 is an even number, my first guess, since I don't know that by heart, would be to say 2. So 2 times 2 is 4, 4 times 2 is 8, 8 times 2 is 16, 16 times 2 is 32, and 32 doubled is 64. So that has to be a 2. I didn't know that one, but I was able to guess on my first try. Now on a problem like number 3, it's the square root. Whenever that number there is missing, it's an invisible 2. So square root of 15, which means we're trying to find 15 to the 1/2 power, or we're trying to find what times what equals 15. Now I don't have that one memorized. I know that 4 times 4 is 16, and if I go down to 3 times 3, that's only 9. So I know it's going to be somewhere in between 3 and 4. But I don't know that number off the top of my head. It's probably going to be some kind of a decimal. So in this situation where we aren't able to figure it out, we would be allowed to use a CAS here, and you could type it in and then just round appropriately to whatever they say. So you can type it in with a square root symbol or the radical symbol here, or you can do 15 raised to the 1/2. Either one of those is perfectly fine. So when you do that, I think you get around 3.9. So it's almost a 4, because 4 squared would be 16. And then the same thing is true on really large numbers like number 4. I would allow you to use your CAS there, and so you literally would just type it in. In particular on this one, I would encourage you to use a rational power because it's very difficult to type in the fifth root using this actual radical symbol. What a lot of kids run into is they say, okay, I'm just going to type a 5 and then the square root symbol and then the 4829, and that is the incorrect way of trying to get a fifth root on your CAS. So you're not going to do it that way, so I'd recommend you writing it as 4829 and then just raising it to the 1/5 power. That will get you the same answer as doing the fifth root. And when you do that, you get about 5.5. So that's the first part of the lesson, is just getting comfortable with the new symbols. Know that it's the same as raising to a rational power. So let's just go a little bit further with this. Let's say you're working with a rational power like we've been doing. Rational power. We've talked about how you need to break it up into the power and the root as two separate pieces. Know that they may ask you to write it in radical form. So the root part of it, the n part of it, would be written with the radical symbol, and the m part of it would still be written as a regular power. So we'll be referring back to rational versus radical form. And so the rational form will be written as an exponent, and the radical form will be written with the radical symbol. So our goal today is to try to convert back and forth between these different formats. Before we can get there, we need to do one quick review of one property. Let's say that you're doing x squared and then you're raising it to another power. So you're doing power of a power. Hopefully you remember from previous lessons, previous chapter, in chapter 7, that you would multiply those powers together to get the 6. You'll need to keep that in mind when we're doing some of the problems that we're doing today. One speculation question that I'd like you to think about is, what if those were roots instead? So what if we had 1/2 and then 1/3? Would we still multiply? That's something that you want to consider. So let's try some of these problems down here. They want you to simplify or rewrite as a single radical. So on this first one, it's a 4th root, and we're taking it to the 8th power. So in this case, we're taking the radical form and we're going to rewrite it in rational form. So the 8 would go on the top because that's a power, and the 4 would go on the bottom because that's a root. And so that's the main thing that you got to worry about on these, is where the numbers are going. Is it a power, which means it should go in the numerator, or is it a root, which means it should go in the denominator? Once you've done that, if you can further simplify, you should go ahead and do that. So 8 divided by 4 is a 2, so we get x squared there. Now we have successfully simplified number 1. So we're going to do the same thing on number 2. It's a very similar question. The 18 is the power, the 3 is the root, so the 18 goes on the top, and the 3 goes on the bottom. I'm just going to use a little caret symbol there to indicate that that is indeed an exponent. When we simplify here, 18 divided by 3 does turn into y to the 6th, and so we finished that one. Now on a problem when we get to one like number 3, now we're not doing a power and a power, we're doing a root and a root. This is where we need to go ahead and answer the question, what if I'm doing a root times another root? Just like what we did on the original property, we would multiply them together. So this would end up turning into x to the 1/6 power. 2 times 3 is 6, and that's on the bottom. So the same thing is happening here. So we're saying we're taking y to the 1/3 power, that's this first one, and then we're taking that to the 1/3 power. So since it's power of a power, we're going to multiply those together, so we get y to the 1/9. So let's try to generalize what just happened on number 3. If you have two roots that you're taking at the same time, two radicals that are happening together, you can simply multiply those together. So let's write a little note here for ourselves in our notes. When you're doing a root of a root, you should multiply the roots together. Typically, you're going to want to write it as one radical symbol or in one fraction form. So know here that we could write it as y to the 1/9, or we could write it as the 9th root of y. So let's do the same thing on our last question here. This is a 6th root of a, hopefully you remember that that's a square root. And so if we fill in that little 2 there just to help us out, 6 times 2 would be a 12th root of x. Or again, you could write it as x to the 1/12. So that's your job today, is to try to figure out how to simplify these and simplify them down to one radical or simplify them down to one exponent. So now that we've learned all the topics for today, let's go back to our challenge problem. So what do you think is going to happen here if we're doing the square root of the square root of the square root? Well, hopefully you know, since it's a square root, those are all 2's, and based on what we just talked about, that should be 2 times 2 times 2 is 8. So we're talking about that being an 8th root of x, and it could be written in either fashion, either in radical form or in rational form. Hopefully you got it right when you guessed. If not, no big deal. Hopefully you'll get them right from now on.